As we discussed throughout this series, what we're trying to do is give a pod access to some type of persistent storage. And so there's a whole kind of programming model and or architectural model here within Kubernetes that allows you to take some type of storage, permanent storage, something like network storage. The examples here are an Azure file volume or an Azure managed disk or data disk, and make that available through this big storage pool which administrators put together. From there, application developers of pods and containers, when they need a data store, what they can do is create a persistent volume claim, which is a request from the storage pool to provide some storage mechanisms for an application. And again, so the diagram here is showing you that typically you will take this persistent storage and put it somewhere that's easily managed, like a network storage pool. So at any rate, let's continue this discussion here today and look at some other aspects of Kubernetes storage. Let's go ahead and expose that pod properly. To do that, what we need to do to expose its IP address is to give it an appropriate label so that when we create a service, it can use the selector to get to that pod. So at this point, if you notice, we do have a pod that's running. Let's go ahead and kill that pod, get rid of it. So I'll say kubectl delete pod task pv pod. We don't need the actual file extension, and I think we successfully got rid of it. So let's see if we get pods again. There are no pods. Let's go now and edit this pod to make sure it has the appropriate label, and we do that over here. We say labels, name, say Nginx, and app. You can do whatever you want here, Nginx app. So now when we create this pod, it's properly labeled so that when we create the service, it knows how to attach to this pod. So I'll create -f, and now it'll have the appropriate label. So let's just verify it is running, and we're good to go. So now at this point, let's go ahead and define the YAML for the service. Okay, so to expose this pod as a service, just to be clear, you can see here that we're going to attach to the Nginx app, right? And so that is used here when we define the pod. We gave the app a name Nginx app, so this is a way that we link up to it through the selector. So we're going to come in through port 8888, and it's going to basically go to the container and hit port 80, which is where Nginx is listening. Notice it says load balancer here. That means that it's a public IP address that will be generated. So let's go ahead and just grab this code here and now create that particular YAML file here for the service. So I'm just going to copy this and go back to the command window and create. So let's go ahead now and create that file. So let's go ahead and paste that code that we had a moment ago. Pretty straightforward here. We've already reviewed what all these things mean here. So let's now just go ahead and run this thing. So kubectl create -f, and then the name of the service YAML file, and that will go ahead and create the service. Now when we go take a look, it'll take a couple moments to actually see the public external IP address. Notice it's pending here for my Nginx service. So let's come back in a couple minutes, and then we'll be able to hit that 8888 endpoint and see the hello from Kubernetes Persistent Storage. We'll keep trying until it shows up with an external IP. So it looks like we got a public IP address. Let's go here to do the curl command, local, we're going to go against the public IP, in this case 165.52.165.190.145, and then of course 48's here, and that'll route it to port 80 of our container where it's listening. Looks like it worked. We can also do this same exact thing from the browser, so I'm going to go ahead and copy this and go to a browser. So I'll just paste this into the window, And looks like we have success. So that concludes all these demos, essentially showing us how we could have persisted storage using a persisted volume in Kubernetes, how we can create a pod that uses a claim to attach and claim part of that storage for its own internal purposes. And so each host has a section of the hard disk where all the pods can access and read for shared storage. So that's it for this particular series. Let's wrap it up right now.